Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 5 on a video about how to look at end behavior of rational functions. So, there's not really a mathematical way to figure out end behavior, but if you remember from the last unit, depending on if the degree is even, odd, positive, or negative, depends on what it is. Now, I'm not going to specify that. You need to look at the video from Unit 4 if you want to see that. You can do that by going on the playlists of this channel and clicking on Unit 4, and then finding the video about that. But in this case, I'm just going to assume that you already know that. So, for rational functions, it's easiest to figure out end behavior if... Okay. End behavior is basically just telling you what does y do if x does something. So as x goes to negative infinity, what does y do? As x goes to positive infinity, what does y do? Let's see how we can figure that out. So if you remember, when the leading degree, when the degree of the numerator is higher than that of the denominator, there is no horizontal asymptote. That means there is nothing like that on the graph. So that's, for example, that. Let's say that's the y equals 3 horizontal asymptote. What does that mean? That means there's no limitations of range. So that means that the end behavior, opposite of what I said, there is a limitation of range, which means where y equals 3. So that means that the end behavior is not going to just be where as x goes to negative infinity, y cannot go to either negative infinity or positive infinity because there is this limitation. But when there's no horizontal asymptote, that means that that there is no limitation, so you can treat end behavior like you would for other polynomials like in the last unit. So let's look at what I mean. So remember, there's no horizontal asymptote if the degree is higher in the numerator. So let's take this for example. So no horizontal asymptote. So that means there's no limitations of range, unless there happen to be whole. So that, let's see what would the end behavior be. So let's just go ahead and write this as x goes to negative infinity, y does something. As x goes to positive infinity, y does something. So if you see, this could be simplified to x to the first, because when you divide exponents, you subtract them. So 2 minus 1 is 1. So if you remember from the last unit, if you have a odd degree, then that means that the arrows are pointing in different ways, like that. And in this case, it would just be like that. So if this really was our rational function, we would know that it would look like that. But regardless, if it's odd, then the things that are right here are going to do different things, the things that you fill in for y. But if it's positive, it will do the same thing as the x, and if it's negative, it will do the opposite thing. It's positive, so that means these are the same things that are going to be here. But that makes sense, doesn't it? Because if you were to graph this, we can see as x goes to negative infinity, y does too. And the same thing as if x goes to positive infinity, y goes to positive infinity as well. So if this happened to be negative, then that would make this negative, and we would see that instead it would look like this, which means that it would be opposite. As x goes to negative infinity, y goes to positive infinity. And as x goes to infinity, y goes to negative infinity. So that's how you can see end behavior of polynomials. Or sorry, well, that is polynomials, but also rational functions. So let's look at a different one. How about we have x to the 5th divided by x to the 3rd. Now, obviously, we know that we could have other things here, whatever it happened to be. I don't know. But we're just keeping it as monomials right now for this purpose. So we can see that this would simplify to x squared. So that means, if we remember the in behavior of even-numbered things, what the y's do are going to be the same because the arrows would point in the same direction. So it would be like this or like this. And because it's positive, it would be like this. So no matter what x does, y goes to positive infinity. So that's how you can see in behavior. Let's look at an example where there would be more than one term. How about 2x cubed minus 2 divided by x minus 5. So it doesn't matter that we have these things, or this coefficient. We still look at the degrees. It's 3, and then there's really a 1 there. So 3 minus 1 means x squared, which means it would be like that because it's positive. So that's how you can see in behavior. And if you can only use that method if the degree is higher in the numerator. If it wasn't, then it would be not what I'm teaching you. So if you want to know how to do that, you may need to ask your teacher, but I'm not going to teach that. So that'll be it for this video. Thanks for watching, and I'll see you on the next one.